Thanks. All right. Welcome to this presentation about advanced item views. Let's see here. I have to press the right button. My name is Marius Monsen. I'm a developer working for Trolltech, and I have been working for Trolltech for 4 years now. And I've been working with the item views in Qt. So first, a little preview. How many of you guys know or have experience with the Qt item views in Qt 4? Hands up. Oh, actually, quite a few. So if you look at this slide, I have a couple of screenshots from some of the demos in this presentation. But if you look closely, you see that not many of them actually resemble the standard item views that we all know and love. And the reason is that my presentation today is not only about, giving you an introduction to item views. In fact, that's not going to be the main part. What I want to achieve with this presentation is to show you guys some of the possibilities of item views in Qt 4, because there are a lot of areas that haven't really been, shown to people, and the item views have a lot of amazing possibilities that we haven't exploited yet. So I want to show some of those possibilities today and hopefully inspire you guys to go back home and experiment with it and find new and amazing ways of using the Qt 4 item views. Let's use the right button there so they get the clue. Okay, so this is the contents for the presentation. I'm going to give you a short introduction. Actually, we're smack in the middle of it as I speak. Then I'm going to give you an overview of the Qt item views, or the model view architecture in Qt 4, and show you how the different parts hang together. I'm going to explain some of the concepts, because we need to understand some of the concepts to sort of go on to the more advanced parts that I'm going to show you. When that's done, I'm going to move on to views, meaning I'm going to show you how to write your own custom view and do some cool stuff with views. This is really what this presentation is about. So I'm going to show you also how you can use the Qt 4 item views to create your own charts, and also show you something new in Qt 4. Actually, one of the cooler parts of Qt 4 as far as I'm concerned, which is the forms. And finally, on popular demand, I'm going to show you guys how to use threads in your models. That's a question I've gotten quite a few times, and I thought it was about time I showed you how easy it is and how convenient it is. And finally, I'll be answering your questions. I mean, you don't have to ask all your questions here. If you don't want to, you can always grab me later. I have this Ask Me thing on the back. That's going to be there for the next 2 days. So feel free to ask me later, too. Okay, before we start on the really heavy stuff, I just want to give you sort of a heads up, because a lot of people that talk to me think that if you dive into item views for the first time, it's a lot to wrap your head around. You have to learn a few concepts, and you have to know a few things to get it working, essentially. And sometimes it can be a little bit overwhelming. The thing is that you don't have to go for the really advanced hardcore stuff first. We actually have sort of a layered approach here, as you can see. In Qt 4, we have the item-based views too, which are very similar to the Qt 3 ones. So that's an approach that most people are familiar with. How many people have actually used the Qt 3 ones? Do you know? Yeah? Huh? And then in 4.2, we added another layer of convenience, which also gives you a lot of the power of the model view approach, which is the item-based model. So you can use your familiar approach of storing your data in items, but you can still get the benefit of the model view approach. I'll show you all the cool things you can achieve with that in a second. And finally, you have the most advanced hardcore level, which I've checked advanced, which is the custom models. Implementing your own custom model is advanced Qt usage. You need to know Qt before you do that. But when you do it, it gives you enormous flexibility and a lot of power to do very amazing stuff. Okay, another thing. I'll just quickly go through the naming scheme we have for the views in Qt 4. We have the list and table and tree that people are familiar with, but we have two different naming schemes. The item-based views are called widget. So you have list widget, tree widget, table widget. And the model-based views are called view. Just so you know, so when you are looking for something in the documentation, you know what the different views are and why they're named differently. Okay, on to the concepts, actually the overview of the architecture here. How many of you guys are familiar with the model view controller design pattern? Yeah, roughly the same number of people that are familiar with model view. Okay, now let me clear up one thing. Qt model view is not a direct implementation of the model view controller design pattern. It is not. It is based on it. It uses many of the ideas, and it achieves essentially the same thing, but it is not a direct implementation of the design pattern. Actually, I have seen very few direct implementations of the design pattern. Most toolkits that have some form of model view architecture have their own variation of this. Okay, so let's go through the different parts here. We can start at the bottom here. Got this nifty laser pointer, so I have to use it, right? So you got this thing, the black box. Now it's a black box for a reason. I'll explain it to you guys in a little bit. But for now, it's sufficient to say that the model is the part that's responsible for managing your data and implementing business logic and such. This is the part that has the data in your application. Okay, moving on to the view. This is the part that's responsible for presenting the data. So as you can see, we have already separated the data from its presentation, right? The view is the part that's responsible for doing things like layout of items. I mean, if you look at something like ItemView, you can see how that works. It is also responsible for receiving user inputs to some degree, which is a difference from the model view controller design pattern, for those of you who care about that. Okay, and then at the top, the hearts, that's the selections. That's the part that's responsible for storing the selected state of your items. So we have actually separated the selected state from the presentation, which gives us some benefits that I'll show you later. And finally, we have the delegate, the happy little guy with the paintbrush. This is the part that's responsible for painting each individual item and also editing each individual item. So if you want things like custom items or custom drawing of items, you will implement your own custom delegate. So the first slide that shows one of the benefits of the model view architecture. As you can see here, since we have separated the presentation from the data, we can do things like sharing the data over different views. And they all look at the same data, and they will all be updated when the data changes. The same goes for selections. Since we've separated out the selections from the presentation, you can share selections between views the same way you share data. So if you select something in one view, it will be selected in another view. Or you can choose, of course, to have separate selections, and if you select something in one view, it's totally different from your selection in another view. That's up to you. But in some cases, it's very useful to synchronize the two. And we do it for you. A really important point, guys and girls. The model in Qt 4, the model architecture, does not provide you the abstract model, the abstract item model, as we call it, does not provide you with a data structure to store your data. It defines an interface that you will implement to be able to communicate your data structure to the rest of the world. The model is just an interface. What the data structure is underneath is something we simply don't care about. The views don't care about it. They don't want to know. They shouldn't know. That means that you can take any view and you can view any data structure, and the other way around. You can take the model and you can say that, hey, my underlying data structure has changed, so I'll just switch this out and replace it with a different model that shows different data or use a different data source. In this case, the data source changed, but the views don't care. They just see a model implementing the model interface, and they show the data. Simple. Now, since we've defined an interface that communicates the data structure, we can do things like, in this case, adding another model into the mix. And this model will just work on the defined model interface. So we have what we call a proxy model. And in Qt 4, we actually supply you with a ready-made proxy model for sorting and filtering data. And the cool thing is that this model that sorts and filters data can work on any model that you provide. We have it working with all sorts of models, from models that expose the file system to databases, to our own custom models with just string lists. It doesn't matter. And you can implement your own proxy model to do other things like data processing, or changing the layout of the data structure, changing a tree to a list, for example. This is a very powerful feature of the model view architecture. All right, so it's actually time for the first demo. I have a few demos to show you. So, I'm not just showing vaporware here. I'm actually showing running code. And you guys will actually get the source code for all my demos later on. So, this is a little example that I made that loads in a text file. It's actually a source file from Qt. And I think, it says the number of lines here, 3,330 lines of code. And what I've done is that I've taken this source code and I put it in a model, and I simply add a filter model and connect the filter model to actually connect the line edit to the filter model. So the line edit will define the filtering expression that I'm using. So what I'm showing is a source model that's being filtered by a sort filter proxy model, and the result is shown in a list view. So let me type in something here. Let's say that I want to see all lines that have the string include in them. So you see how the number of lines were reduced live, because every time I push a button, the filtering expression will change, and so the filter model will filter out all the strings that don't match the expression that I'm using. So this is a very simple demo. I'll show you a little bit of the source code for this, and it's achieved in amazingly few lines of code. This is essentially the main function in the demo. All I'm doing is instantiating a sort filter proxy model. I'm setting the source model on the filter model and creating a view that shows the filter model. So I'm, chaining the source model, filter model view. And then I connect the whole thing up. So I connect the line edit text change signal to the filter model set filter RegEx, which sets a regular expression that I'm going to use for filtering. And hey presto, we have something that filters items. All right. So I've explained some of the features of model view. Now it's time to look at some of the concepts. Are there any chess players here? Yeah, one, two, a couple. Cool. Now, I'm not a really good chess player, but I know that the really good chess players are able to play a whole match in their head. They don't need a chessboard. They can just imagine how things are laid out, and you can tell them that I'm moving the piece in this position over to this position over there, and they know what's going on. This is kind of the same idea that we're using in the model interface. We are using the concept of tables in the model interface. We want to express data structures as tables. Can you turn that off, please? Thank you. Okay, so we want to use the concept of tables. As you can see here, here's one example from our model that shows the file system. This shows a part of my home directory, not all of it, but it's laid out in a table. So it has 4 rows and 4 columns. The thing is that a file system is not flat. It's a hierarchy. So I express it as a hierarchy of tables. In this case, only the items in the first column can have children. But when they have children, they can have a table of children, as you can see here. That's the main idea of the model interface. If you can grasp that, you're pretty far. So the way we use this is that we do the same as the chess masters. We indicate positions in the data structure. So when somebody tells a chess player, I will move the piece in G1 to, say, F2. Now, the chess player knows what you're actually trying to do now. He knows that the piece in G1 is actually the white horse, or knight. And we do the same thing. In the interface, in this case, the delegate will ask the model, please give me the item in row 1, column 0, and then some additional information that I'm going to explain. And it will give it, the model will then give the delegate something that indicates a position in the data structure. In this case, it references the desktop item. This is actually how we do it in code. And what we do is that we have a little class, a lightweight, short-lived object that we call a model index. And it contains the information that we need to find something in your data structure. In this case, we get the model index from the model, and we want the model index at row 7 and column 6. Now, we know how to reference items or in your data structure, but the thing is that items are not just items. They're not just one piece of data. If you look at an item view, you will see that each item consists of several pieces of data. So we have to have a way of referencing the different pieces of data in an item. And the way we do that is to assign them roles. So in this case, we have an item that has a pix map or an icon. It has text, and it also has some value that is expressed as a checkbox. We have several other possibilities. We can have tooltips, background colors, things like that. What we do is that we assign each piece of data a role so that when we ask the model for a piece of data, we indicate the position in the data structure, meaning the item, and we give it a role which indicates which piece of data in the item we're interested in. Kind of like if you were playing chess again, you would ask, what is the color of the piece at position G1? In code, we would represent this like this. We would get the model index for the position, and we will then ask the model for data at the position and for a certain data role. Now we have a shorthand version of this, as you can see in the last line here, where we have a convenience function in the index that will give you the data you're asking for that position. But essentially what's happening is what you see in the first 3 lines here. All right, so that was a whirlwind tour of the model view architecture and the concepts behind the model interface. So let's just sum up the main points here. The item model is the interface to the underlying data structure. It's a defined interface that enables us to communicate about data structures and data in a generic way, which gives us the possibility of changing out the model or the views as we please, really. Then we have the model index. It's a short-lived, tiny object that indicates a position in your data structure. And finally, we have the item data role, which indicates which piece of data of the item we're interested in. Cool. That was the first part. Now we're on to the cool part, which is how to write your own custom views using these concepts. Now, you don't have to know all these concepts in detail. I don't expect you to suddenly become model view experts in half an hour. So this is to give you an overview so you can follow the next part of the presentation. Don't worry if you don't remember all the details. Okay, so we have something that requires us to create a custom view or visualize our data in a customized way. The default views don't suit us. We need something different. Now we have 3 approaches that we can take to do this. And I've shown you all the 3 approaches here. If we just want to have the items look or behave a little differently, we want to essentially do custom item painting or custom items. And the way to do that is to re-implement the item delegate, that happy little guy with the paintbrush that I pointed out in the beginning. That's the little guy that's responsible for editing and painting each item. Now, if we're not really interested in painting individual items, but we're interested in doing different layouts, then we want to re-implement a view. We want to create our own view. And finally, if just a view or just a different layout is not sufficient, we want to do something completely, radically different with our data. We want to do custom visualization. Now, we may still want to re-implement the views to do our custom painting, but it could also be that we're just creating our own widget subclass and using the model interface ourselves. My demos are going to subclass the QAbstract item view, so they will be item views, but some of my demos will actually not use Delegate to paint items. It will paint items or the data in a completely different way. So let's look at the item delegate. At the danger of repeating myself here, the item delegate is responsible for painting individual items. It's responsible for managing the geometry of individual items, the position of the different data elements. It's also responsible for editing individual items. And finally, it handles some input events. The view will forward some input events to the delegate, so we can do things with those events, and I'll show you how to do that in a second. All right, it's demo time again. So this requires me to create a whole, or select a whole bunch of images. And please note that it takes a little bit of time to load all those images. In the threaded part of my presentation, I will actually show you how to make this a lot faster. So we have a bunch of items. They're painted in a special way. Actually, I've simplified the painting code so it only paints a pix map. So you see no text. And all the items are painted with the same image. But what happens when I move the cursor over one of these items is that I have an animation that shows a preview. And I can have several animations going at one time. Okay, so let me show you how I did this. What I did was that I have my own special delegate that has very simplified painting code and very simplified code for giving the size int for an item, which is something you have to do. I also have a separate mechanism for handling the animation of each item. The painting code, this is what you will see in the header of the delegate. This is the paint function that you need to re-implement if you want to do special painting. So what do we have here as arguments? Obviously, we have a pointer to the QPainter that's being created in the paint event of the view. We also have a reference to something called a style option structure, which contains information about the state that we're going to paint. For example, if the item is selected, if it's current, things like that. It also contains the rectangle that we have to draw and a few other bits and pieces that we may or may not use to draw the item. And finally, we have the model index, the little object that indicates a position in the data structure of the model. So we know which item we are going to paint, and we have a way of getting to the data. So here's the first part of the painting code. Basically what I do is that I use the model index that I got as an argument, and I get a piece of data from the model. In this case, it's a pix map, And I've also defined my own special PixMap preview role, or actually preview PixMap role. So as you can see, you're not restricted to the previously defined data roles in a model. You can define your own special roles, and you can use them in your own delegates or views as you want to. So I have the preview PixMap. Let's see. And similarly, I also have a PixMap for the icon that you saw, which is the same code basically. So I have two PixMaps. So the animation actually consists in just scaling those PixMaps horizontally, depending on which frame in the animation I'm at. So I have two PixMaps painted side by side, and when I animate them and one becomes bigger and the other becomes smaller, it almost looks like it's rotating. Not quite, but almost. This is basically what we're doing here. We're getting the frame number from the Animator object, and we're drawing the PixMaps. This is the painting code in the item delegate. Painting code. And then let's look at the animator, the thing that actually controls the animation. It's not really complicated either. First, we have a data structure that holds information about the animation. As you saw, we could have several animations running at the same time, so we need to store these states in some sort of structure. So we have the frame, we have the increment value. We could have a default of 1, but it's nice to be able to speed up the animation by adding more. And you have the count, the number of frames, and so on. Now, the important part here, I've tried to highlight it in bold, is the QPersistent model index. Well, that's a long name. Now, I told you about the model index. And I also said several times that it's a small, short-lived object, meaning it contains information about your data structure. But what happens when your data structure changes and you still have model indices out there in your program somewhere? They're going to go bad. They're going to be out of sync with your internal data structure, which is why we're saying that you should never store a model index. Use it as arguments for functions, get it from the model, use it to what you want to use it for, but never have it hanging around in a data structure, because it's going to go bad once the model changes. But sometimes it's useful to have references to pieces of data in your model stored somewhere. And this is where the persistent model index comes in. The persistent model index is going to be updated by the model when something changes. Whoever implements the model is going to have to give the right signals, call the right functions, and give notice to the implementation or our base implementation of what's happening for the model indices to be updated. But if it's done right, the model indices, the persistent model indices, are going to be kept in sync with your data structure. So when you store a model index, a persistent model index, you're sure that it's either going to be invalid or it's going to be updated to whatever's happening in the model. So then the question is, why don't we just use persistent model indices all the time, right? Well, the answer to that is that even though the persistent model indices are not that heavy, they're actually pretty lightweight, it does add a little bit of overhead for the model to maintain the persistent model indices when something changes. So it is good form that you keep as few of the persistent model indices around as possible, so that the model doesn't get bogged down with maintaining, a list of 1 million persistent model indices every time something happens. All right. So the Animator class itself, it's very simple. all it does is keep a list of the different animations that were playing at this point, and it keeps a pointer to the view, so it can tell the view to update itself. And it has a timer ID, so it can, listen to the ticks of a queue timer and update the animation. And again, you are going to get the complete source code for these demos, so don't worry, you can look at all this later and play around with it and change it and have fun with it. Right. So that was animations in individual items. Now I'm going to show you something that's pretty cool, actually. At least I think so. So this looks like a pretty ordinary icon view, right? It shows a list of files from the file system. But it does actually have a custom item delegate. And what I've added is that when you hover with your mouse cursor over an item, it will show a series of small icons, actually, that represent actions. And in my delegate, these actions are normal queue actions that you add to the delegate, and they will send out triggered signals when you click on them. So if I click on one of these actions, say a little smiley face down here, I've just connected it to a message box, but you can connect it to whatever functionality you want, and you will get the mol index as an argument to the signal, so you know which file was triggered, which file I'm referencing. So it's a very simple demo, but it opens up a lot of possibilities. I mean, having the small actions in a circle around the item might not be the best thing to do usability-wise, but I know that people have been experimenting with having small icons in the corner of items and things like that. So really, we have the possibility to do a lot of new stuff usability-wise with item views. We're not restricted to the old way of doing things. So let's take a look at how I actually did this. This actually uses a part of the item delegate that hasn't really been exposed a lot. People don't really know much about this part of the item delegate. And that's the possibility of receiving user input events in the item delegate. So we have a virtual function in the item delegate called editor event that will receive events from the view along with a pointer to the model and the style option structure and also the model index, so we know what item we're talking about. So what I do is that I simply re-implement this function, and I have a list of actions registered in my delegate, and for each action I have registered, I just call them with the event and some information about where this happened. And in the action event function, I go through the events and handle the events that I want to handle. And in this case, I want to handle the mouse button release event, because that means that somebody actually clicked on my action and released the mouse button. And in this case, I emit a signal, as you can see. I also changed the active state, so it's drawn a little bit differently to give the user some visual cues that actually something happened. All right. So that was custom item painting and also custom item event handling. Now we're on to re-implementing the view and changing the layout of items, which was the second approach that I mentioned. Okay, so ladies and gentlemen, I give you the musical revolving cake plate, something every household should have, right? Actually, the example I'm going to show is inspired by a Microsoft research paper I read a few years ago, but the idea is very similar to this, actually. So how do we actually implement a view that's based on the revolving cake plate? It's going to be a challenge, right? Now, just to, pound in the point here, this is one of the old boring layouts that we have, right? In an icon view, you go from left and you hit the wall and you start again. That's pretty standard, not really hard to implement. But to get the cake plate layout, we want to start with laying out the items along a circle. So we need to do a little bit of trigonometry and math, but really plotting points along a circle is not really hard to do. So I'll just show you the code for doing that, which is pretty obvious. So that's plotting the points along the circle. The thing is that in addition to laying out the items on the circle, I also want to have some animation transitioning when I select an item. So I add a little bit of complexity here by adding a variable t representing the time of the animation. It's going to be a value between 0 and 1. I also add index and start because we're not operating with just one item, we're operating with several items. So index would be the current item we're working on, and start would be the first item in the layout. And through some steps here, we end up with a position on a circle for each item. So let me show you what I ended up with. So here we go. Nice little circular layout of items in my file system. As you can see now, when I change items, it animates and rotates. So it's kind of neat, but still, it's not really the musical revolving cake plate that I envisioned, right? It's still just a circle that we see from above. It would be nice if we can add some sort of 3D element to it, so it, comes out towards you. Did I hear somebody go here? That's going to be hard. Okay, let's see how we would do that. Now, one thing before I show you the next slide is that now we're sort of diving into the muddy waters of computer graphics, right? We're going to introduce something like 3D, and we're going to do special drawing and stuff. And one thing about computer graphics is that it's one of the few areas where it really pays off to lie, steal, and be sneaky. If you can get away with, doing as little as possible, then you do it, even if it's cheating like crazy, right? So you will never, you can never trust computer graphics because what you see is never the reality. They're always cheating. And so am I. And I'm going to cheat. I'm going to give the user the experience of, semi-3D layout. But what I'm really doing is I'm just scaling the painting of the items. So I'm using the Y position of the items so that the bottommost item is going to be larger than the topmost item. And I'm also going to lay out the items along an ellipse instead of a circle. And together, those two elements will give the impression, or close to the impression, of 3D layout of the items, right? So let's see how that works. There we go. Now it's been laid out along an ellipse, and I scale the items based on their Y position. Now, this works pretty well, when it's within certain parameters. It looks almost convincing. But of course, since I'm really cheating here, if I push the limits a little bit, you see that my model breaks down, right? Now it looks really crappy. So when you're cheating, it's important to, keep the view within certain boundaries, the safe boundaries where your illusion is convincing, which goes for most computer graphics, right? All right. So that was custom layout. Now we're on to custom visualization. And in this part, I'm not going to deal with items at all. I'm not going to deal with layout. I'm going to use the model interface to show data in a completely different way. I mean, I'm a programmer, so I'm lazy, so I'm going to reuse code. I'm going to use my code for, plotting points on a circle. So what can you do with plotting points on a circle? Well, if you do that, you can end up with something like that, which, you can envision that this might be useful, say, if we color each segment of this circle, right, based on some data. So this is basically what I'm doing. I have a model with data, and each item has a value, and I'm going to color the number of segments proportional to the value of each item, which gives me, a pie view. Let me show you the demo. So here you see I actually have two views. I have one view that is a normal table view, standard, what we ship with Qt 4, and it looks at a model with some data in it. And then I have my pie chart that unfortunately has some drawing errors, but nonetheless, looking at the exact same model. So if I change the data in one of these items, say I want the green to only be 5, you see that the green segment in the pie view now is shrunk to almost nothing, right? Now, I mentioned that graphics is about cheating and stealing. We can achieve the semi-3D effect that you see on the slide by being sneaky again. So here, what I'm doing is exactly the same as I did with the custom layout. I squeeze the circle into an ellipse, and in this case, I also take the lower points and just translate them a little bit down and fill in the polygons with a darker color. And it looks somewhat semi-3D, kind of like what you see in the charts in, say, Office or something. So, I'm still not happy with the pie chart, though. I mean, it kind of works, but it doesn't look amazing. So I'm going to introduce you guys to a new feature in Qt 4.2, and that is the ability to set your own viewport on item views. Now, I'll have to explain to you guys. In Qt 4, the item views consist really of two widgets at least. We have the view itself, and then we have the viewport inside, and it's the viewport that we're actually painting on. We have a few other widgets like scroll bars and headers and whatnot, but we're not going to care about that. We're going to care about the viewport, the view that we're actually the widget that we're actually going to draw on. Now, another cool thing about Qt 4 is that we have our paint engines, which can be implemented to draw on using OpenGL, Pixmap, whatever you really want. So you can have custom paint engines. And together with the ability in Qt 4.2 to change the viewport widget, we can actually change the viewport widget to be an OpenGL widget, which suddenly changes our item view to be able to draw 3D graphics using OpenGL commands directly. You can actually still paint with the QPainter commands, and you can mix the two. So you can mix OpenGL commands and QPainter commands at your will. All right. So here I draw a few. I actually draw a triangle using OpenGL commands. This is part of the next demo I'm going to show you guys. Because you saw that when I was painting the pie, I was dividing the circle into triangles. Triangles happens to be a very, very common polygon to be used in 3D graphics. Most 3D graphics libraries operate with polygons at the lower level because they're very easy to draw. So let me show you the OpenGL version of the pie chart. Some demo effects there. Right, so here we have an OpenGL version of the pie chart. It's still an item view operating on a model, and the table is looking at the same model. So if I change something in the table, you will see that it's still reflected in the OpenGL view. And as a final bonus, I'll show you another demo with another model. Here you can see that, again, some demo effect. Here you can see that the data in the model is constantly changing. And as you can see, both views are updated to reflect the changes in the model. In the table view, it doesn't really look that interesting. You see some numbers, scrolling by. But as you can see in the bar chart there, they actually represent, can be represented with the height of some bars. Okay. Yeah, can we take questions afterwards? I'm a little bit short on time, I think. So now on to a part that I think is incredibly cool. It's not something that the marketing department has really been aware of, I think, because it's not really eye candy. But this is probably the coolest feature for item views in a long, long time. And actually, the author is here in the hall. So now, the thing is that item views up till now has been just about having dedicated views and a model, right? And you can switch them around, and it's cool and all, and you can have your own custom views. But the new forms, the widget mapper, as we call it, is now possible to connect any editor widget with a position in a model. So you can create forms. You can take a line edit, connect it to a position in a model, and the line edit will control that item. If you edit the line edit, it will be updated in the model. If the model updates, the line edit will be refreshed. And I have a very simple demo here. I'll have to explain some concepts here. What we have is called a data widget mapper. It sort of functions as a negotiator between the model and the editor widget. And it uses the meta object features that we have in Qt, the properties, in ways that I'll show you. So the way you use the widget mapper is that you say that a widget is going to control a column, for example. You can choose the direction horizontally or vertically. In this case, it's horizontally, so I'll choose a column and say that the top line edit is going to control column 0. And then the dial is going to control column 1, and the data edit is going to control column 2. And then we say that the data widget mapper has a current index, so it has a current row, right? So it controls, in this case, it's the last row that's being edited. And the way it works is that we use the thing called the user property. Qt4 has the ability to set certain, some bits on properties. And we can define a property as a user property, meaning this is the value of the widget. So in the line edit, for example, it's the text that is the user property because that's the value that's going to be edited by the user. And the widget mapper can look at the properties and find a user property, and it will automatically use that in the mapping to the model. So it will automatically use the right property and use that to control the model. And setting it up is amazingly simple. You simply have a model, you instantiate the mapper, and you set the orientation, in this case horizontal, and you connect that to a widget. So in this case, it's line edit, and we set a column that we connect this widget to. So now the line edit controls the column 0. And the result is as follows. So here we operate on the same model again. We have two views. We have a dialog that I have composed, and we have a table view. And each widget in this dialog controls a column in the model. So if I change something here, say the value on the dial, you can see that the value is changing in the table view. You can do this, and you can see that it's updated live in the table. It's not very flashy, but it's amazingly powerful and I think really cool. I mean, the underlying model could be anything. Could be a SQL database model for that, Okay. Final part, and I'll have to be quick with this, I think. Imagine we have 3 friends here. These 3 friends want to write a movie script. They all have amazing ideas for a movie, but they only have 1 sheet of paper to write it down on. So, those of you who are familiar with thread programming can already see the problem here, right? How many of you are familiar with threads? A lot of you. Cool. So, how do we solve this problem, right? Well, the standard way of solving it is, of course, to have a lock so that only one person can write down his ideas on the paper at the same time. So, and we have classes in Qt for doing this, and it's actually not that hard to do this. But we also have another solution to this. And that is, what if instead of trying to grab the paper and the pen and, fighting the other guys for access to the paper, they start talking to each other. And they might select one secretary that's supposed to write all this down, and the other guys are going to just, tell him the ideas they have. And you can do the same in Qt. This is an important point here. So I've kept it simple. Signals are safe. In Qt 4, signals are thread safe. Signals are your friend. Use them. So I have a demo for you, of course, that uses threads in a model. And what I do is that let me explain something first. The idea for this demo is something I actually borrowed from a friend of mine, Mirko Böhmer, that has a threading library that you might want to look into. That's called Threadweaver, which is pretty cool. But I kept it a little bit simpler because my needs are not that advanced. Now, the idea behind this demo is this happened last year too for you guys. Okay, the idea is to use the fact that a normal computer, even if it's only got one core or one CPU, can still do several things at the same time. Because we have a separate I/O system and a CPU, right? The CPU is normally not bogged down when you do something on the disk. You can still do tasks on the CPU. And we're going to exploit this by doing separate tasks at the same time. And what I want to do is that I want to load a series of images and I want to scale them. And there you have two different tasks that use two different parts of your computer, right? The loading uses the disk, it uses the I/O system. Whereas the scaling uses the CPU. So this is what I've tried to show here on this slide. So what I have is I have a pool of threads that each do two things. It loads and it scales, and then it loads and it scales again. And the idea is that even on a single CPU machine, hopefully we'll end up with one thread loading while the other thread is scaling, meaning one thread is using the I/O system, whereas the other thread is using the CPU. And you can already see that we get a huge benefit from this. And finally, I'm not going to block the threads when I write the final scaled image to my main GUI thread. I'm going to use signals. So this is how I, initiate the whole thing. What I do is that I have a list of threads called workers. So I work the threads, and for each thread in the beginning, I call start on the thread, and the argument is a list of paths for the images that I want to load. So each thread gets a list of the images that I've decided it should load for me. Of course, the sort of important part here is that I've decided upfront which thread is going to load which image. So what I do is just take the whole list of images and divide it up into the number of threads. All right, and this is the scaling part, and also, actually, it's the whole thing. Because first, we load the image. You can see there when we create the original. We scale it, so we create the preview. And finally, we emit the done signal, which is the signal that eventually is going to have the data written to the GUI thread. And now it's a good time to remember when I had my iCandy demo, you noticed that it took like a second or two before anything happened while it was loading the images, right? Now, let's see what happens when I use the threaded version. So I do the same thing. I select a whole bunch of images, and I load them. Now, you see that even if it's, loading, it is still interactive. It still updates because the GUI thread is still painting. And for each signal that's being sent by the model, it is going to add a new image or a new preview to the view. And so even if we're on a system that's going to be just as slow as a single-threaded one, you will still get a faster responding application that seems to be, the user gets instant feedback when he starts something, and you can interact with the application even while it's working. So, to summarize my presentation today, these are the points that I want you guys to remember when you walk out that door today. This is the important part of the presentation. First part, the model concepts. We start out with remembering that the model is not a data structure for you. It is an interface. It defines a way to communicate about data structures. And then we have the model index, which indicates a position in the model. And finally, the item data roles, which indicates the different data parts of each item. Then, for the customization, there are 3 approaches for customizing the views. You have the per item customization, where you re-implement the item delegate. You have the layout, the customized layout, where you re-implement the view. And finally, you have the customized visualization, where you also may or may not choose to re-implement the view. You can also just have a QWidget subclass and use the model interface. Then we have the forms, one of the cool features of 4.2. And finally, threaded models. Models are safe. Use them. And that's my final slide, some URLs for further information about this. You can also search for this on the doc.trolltech.com. That was my presentation. So thank you guys, and I'm ready to take some questions if we have time.